class, welcome back to the unit on right triangles and trigonometry, and we're going to wrap this thing up with some, real-world application with angles of elevation and depression. Oh, sad. Anyway, angles of elevation, depression is our last lesson of the unit. We're going to talk about identifying what they are and, more importantly, what they are not, and then how we use them in some real-world applications, and of course that's going to involve our favorite, trigonometry. So let's jump into a couple of notes. So we got to figure out what in the world is an angle of elevation and an angle of depression. So consider a diagram like such, where you have a person who is looking up at a thing. And you have, in that case, the person looking at a thing, looking up at a thing. We now have, in that perspective, we have angles of elevation, which is from the person's point of view, and an angle of depression from the thing's point of view. Okay, so why then does this involve trigonometry? Because we are dealing with right triangles. The horizon in an angle of elevation acts as a right angle for the height of the thing being looked at, okay, or the height of the thing in consideration. And then from the object, we also have a right angle coming down to where the line of vision began. So this involves trigonometry because we are dealing with an angle of elevation and an angle of depression. So this is where things become important. I'm going to share with you a couple of notes. The first thing is a warning. Be sure to know what the angle of depression is not. Okay, so we have to know what the angle of depression is, but more importantly, what it isn't. Okay, so what we see here in this diagram, here is our angle of depression. There. What it is not is this. This is not the angle of depression. Okay, so that is not the angle of depression, and that's going to become confusing later on. So I'm going to caution you to come back to that part of the notes. The angle of elevation from the ground object up. The angle of depression goes from the object in the sky coming back down, not inside the same triangle. Okay, so we have to be very, very cautious with that warning. Make sure we understand what the angle of depression isn't. Hopefully you notice some interesting stuff about the relationship between the two angles, the angle of elevation and the angle of depression. Right? So when you look at this example, both angles are 38 degrees. And that's something that can help you with the warning. Okay, so make sure you understand that the angle of depression would be congruent to the angle of elevation, and see if you can tell me why. Because horizontal lines are parallel. The line of sight is a transversal, and the two angles are alternate interior angles. Okay, so it's interesting to help you with knowing what the angle of depression is not, is to recall that the angle of elevation and the angle of depression are alternate interior angles, therefore congruent to one another. Finally, another word of caution, another warning. The line of sight from a person is the eyes, not the feet. And of course, you would read that and say, well, duh, Mr. Katz. Yes, duh indeed. Because take a look at this diagram. We have some person looking up at an object. How high is the object from the ground? The ground is where the person is standing. Okay, so we got to remember that a person looks from their eyes, not their feet. And that will have some interesting segment addition postulate repercussions later. But that is a fair warning. Hopefully you heard that warning and are thinking, oh, that makes sense. So be sure that we are using caution when dealing with height. All right? So we're going to refer to these notes back and forth, but in the meantime, let's get started with some examples, some identifying things. Okay. So what we're going to do is identify what are the angles of elevation and depression, and what are they referring to, and what do they relate to. So here we have a diagram of a lot of things happening. We have, of course, a hot air balloon, a person in the hot air balloon, a person looking at two things. The person can look at the bird in the sky, and the person can look at the base of the hill. Okay, so the person is looking at two things. So we have a lot of relationships here with angle of elevation and of depression. So the first question is here. What is the description of angle 1 as it relates to the situation? So let's take a look at angle 1. What is the description of angle 1? Angle 1, hopefully you can tell, according to our notes, angle 1 will be an angle of depression. Okay, so that's an angle of depression. But what is it in relationship to? It's an angle of depression from the person to the bird. Okay, so from person to bird, it's an angle of depression. Okay, so from person to bird. So we want to make sure that we understand that situation. So that's an angle of elevation, the angle of depression from person to bird. That is what angle 1 is. So make sure we're able to identify that. Second question, what's the description of angle angle 4, I can't read, as it relates to the situation shown? So we're going to look at angle 4. So what is angle 4? Now angle 4 is down there, so what's happening there? Angle 4 is an angle of elevation from the foot of the mountain, from the base of the hill, up to the person. So that is an angle of elevation. Okay, but it's an angle of elevation from the base of the hill, okay, so I'll say from the hill for short, from the hill to the person. So that's what's happening with angle 4. All right, so make sure we understand the vocabulary. And then lastly, what is a description of angle 2? Okay, so here we have angle 2. What is the description of angle 2? This is an interesting one, right? Because angle 2 is only from here to here. You follow? So what in the world is angle 2? Well, see if you can guess. If you need a hint, remember the note, right? So angle 2 is an angle of elevation from the person to the bird. Okay, so that's what angle 2 is. It's an angle of elevation from person to bird. Okay, so that is our vocabulary. That is our vocabulary. So it goes from person to bird. Now, how are we going to use this in some examples? Let's take a look. This is very important vocabulary because the math is not easy, but we've done the math in the previous lessons, right? Now we're just using these real-world examples. So let's come on, cats, turn a page, will you? So take a look at our first example. We're going to use the angle of elevation, and I think after this example, we'll call it a day. And we'll do some more practice in the next video. So here's our angle of elevation. We're dealing with a wind farm. Suppose you stand 53 feet from a wind farm turbine. Okay, you're standing 53 feet from the wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. So the angle of elevation to the, I guess that's called a hub now we know, is 56.5 degrees. Your eye level is 5.5 feet above ground. That's important. 5.5 feet above ground. Remember my last word of caution. We look from our eyes, not our feet. Okay? We look from our eyes, not our feet. So that's an important thing. So the eye level is about 5.5 feet above the ground. Approximately how tall is the turbine from the ground to the hub? So the question is asking for the entire height of the turbine. Okay? But look what's happening. We have a triangle, a right triangle, with your horizontal line of sight, which is only from here. We have our 53 feet from the base. We have our angle of elevation. We need to find the height of this of the turbine. But we need this piece of the turbine, so then we can use the segment addition postulate along with the height of our line of sight, and then we can find the hub. Okay, so that's the situation that's going on. So in order to make things a little bit clearer, let's draw a better picture of what's happening. So we have 53 feet here. We have a degree measure of 56.5, and we're going to look for this. Okay. Now, what is happening here? Hopefully you remember trigonometry from the previous lesson. If you don't, you better stop this video and go back and watch the previous lesson on trigonometry. Because what we're dealing with is Chief SOHCAHTOA again. Good old SOHCAHTOA. So he comes back, or she. Why gotta be a dude? So Chief SOHCAHTOA comes back. We have our our angle here, and we have an opposite leg and an adjacent leg. Remember I said in that last video, tangent is a useful thing, and now we see why. So an opposite leg and an adjacent leg. So we'll be using the tangent function. We're going to want to take the tangent of 56.5. And like I said, if you don't understand what just happened there, dude, stop the video, go watch the previous one. Anyway, the tangent of 56.5 is going to be the ratio of x to 53. Okay, so that's how we're going to figure out what x is. Now it's going to solve the equation. How do we solve? We're going to multiply both sides by 53, and then we find out, well, that x is 53 times the tangent of 56.5. So once again, we're recalling that this trig function is actually an operation that we can perform on a degree measure. So bust out the handy-dandy calculator, and we will compute 53 times 56.5, the tangent. Okay, now we have this crazy number, which doesn't make any sense because I'm going to try it again. 53 times 56.5 tangent equals. There we go. I didn't hit the equals button. I did that again. So we have 80.07. That's the deal. But we want to read approximately how tall is determined. So all we need is an approximation of what's happening here. So look at our figure that we had in the calculator. It's approximately 80. Okay, so we're looking at x being approximately 80 feet. But is that the answer to our little riddle? And of course, no, it isn't, because once again, we don't look with our feet. Remember, we are looking at 5.5 feet above ground, so the segment addition postulate. So only from our line of sight to the top is 80 feet. Well, what about from the top all the way down to the ground? We will have our 80 feet plus our 5.5 feet. So how tall is the turbine from the ground to its hub? A combined total of 85.5 feet. And that's how that works. Yay, angle of elevation. Yay, tangent. And now you can see why trigonometry is used in the real world. I'm going to call it a day for this video. We're going to come back and do a lot more practice. Okay, we're going to do practice, practice, practice for the rest of the second video. But that is an introduction to the angles of elevation and depression. So when we return, we'll do more practice. Take care.